Okay, so the purpose of this video is to review this assignment that I have that we're working on. It's called the phet projectile motion honors physics is the name of the file. But basically, we're going to start out, and there's a few steps here we go through, and you should be looking at the paper that you did while I go through this. I'm going to be looking at it as well and referring to this. So to start with, you should have ended up on. Let's hide that. On the intro tab, and we'll clear all. In the intro tab, and we would clear all. And you begin to play around. One thing I hope you noticed is that you can make it smaller and bigger in a few different things. But the first thing that it asks you to do is to set the cannon to 10 meters. And I've got that set here, 0 degrees. And I've got that set there with an initial speed of 20 meters per second. And then it says to turn on all of the vectors. We do that right over here. Leave air resistance off. No pumpkins, please. We're just going to do cannonballs. And now you're just going to play it one time. Hit the button and fire it. There we go. Now we're going to change it to slow, as it says there. It says to click the slow button. We're going to fire it again. We're going to hit pause as soon as we can. And then we're going to click the step button through here. You can do it. You hopefully did it a couple of times. We can see this kind of changing through here. And I want to talk about a few different things here as we go. So let's do this again. It's actually stepping along now. There we go. So the first thing it asks you is, what do the green arrows represent? And so if you look at these greens, hopefully you checked over here, you saw green. Well, those are the velocity arrows. What do the yellow arrows represent? Yellow is for acceleration arrows. We're now looking at number 2 in case you've lost where you're at. Number 3 says, why is there a bold green arrow and how does it change as the ball follows the trajectory? Well, this bold green arrow is actually, that is the instantaneous velocity of this projectile as it follows its trajectory here. At any given time, its angle and speed is represented by this green arrow. And so it's actually tangential to this. This isn't a true arc, but it's tangential to that point. And one thing to notice is it actually does get a little bigger as it goes down. If you don't believe me, you can measure it with a piece of paper. I proved it on the screen in one of the classes. We were able to do that. But the reason why is, remember, this is a resultant vector. That's the result of the x component plus the y component. And so watch this y component as we step along. Due to accelerating this way, this y component is getting larger and larger. So that y component is actually being added to the x component for this resulting vector. So this gets a little bit longer. Essentially, the ball's doing a little faster by the time it hits the ground. And you can see that this, on the y-axis, the velocity is increasing. That's due to gravity. And that's actually getting on to number 4. What axis is the light green arrow on? That's on the x-axis. What axis does the light green arrow not change? Sorry, the answer to number 4 would be the x and the y-axis. Number 5, which one does it not change on? Well, that's the x-axis. If you look at that throughout the entire thing, we can fire it again. If you look at it, this never changes through the entire time it's flying through the air. The x-axis is always staying the same. So that would be the x-axis. Number 6, the correct answer there would be the y-axis, because the y is changing. You'll notice, as we've already seen before, it gets bigger and bigger. That's because the object is speeding up in this direction. Remember, these arrows are showing the velocity of the x and y components of the velocity at any given time. Looking at number 7, the correct answer would be the y-axis is on the yellow is on the y-axis. And does the size of the y ever change? No, it's exactly the same. The acceleration is always the same. It stays the exact same size. Check out this. Even though now it's actually going, well, what's going on there? Well, the acceleration on the y-axis has caused the y component to continue to get larger and larger. The correct answer number 9, what is the source of that acceleration on the y-axis? That is gravity. The correct answer to number 9 would be gravity. You want to make sure and understand why that is. Thank you. This concludes numbers 1 through 9. We will continue the rest of these numbers in another video.